Have you ever really stopped to think about what's happening inside your computer? Like when you click a mouse, or how your phone can magically pull up information from anywhere in the world? Well, we're going to pull back the curtain on all of it. In this explainer, we're basically going to build a computer system from the ground up, piece by piece, from the tiny parts inside the case all the way to the huge global networks that connect everything.
You know, it's kind of wild to think that the first computers were absolute behemoths. We're talking machines that filled an entire room. But now, thanks to some incredible engineering, they're literally everywhere. They're not just on our desks anymore. They're tucked away inside our digital cameras, our cars, even the elevator you ride. Tiny little computers are silently running the world all around us.
So what even is a computer, really? Well, at its core, a computer system isn't just one single thing. It's more like a team. You've got the hardware, that's all the physical stuff you can actually touch. And then you have the software. Those are the programs and all the instructions. The two of them have to work together perfectly to store, find, and process all the data that makes our digital lives possible. All right, to really understand how this team works, we need to pop the hood. So let's head inside the main computer case, the system unit, to meet the most important components, the brain and its essential support crew. And this, right here, is the foundation of the entire system, the motherboard. You can think of it as the central nervous system, or maybe the city grid for the computer. It's the main circuit board where absolutely everything plugs in. It connects all the components and makes sure they all get the power and resources they need to talk to each other. Now, sitting right there on the motherboard is the undisputed star of the show, the CPU, or the Central Processing Unit. This is, for all intents and purposes, the brain of the whole operation. Every single command, every calculation, every instruction from every program you run has to be processed right here by the CPU. But a brain can't do its work without a place to think, right? It needs a workspace. And that's exactly what RAM is. RAM, or random access memory, is like the computer's short-term memory, or its workbench. It holds all the data for the apps you currently have open so the CPU can access it instantly. But here's the catch. RAM is volatile, which is a fancy way of saying the second you turn the power off, poof, everything on that workbench disappears. So if RAM is just temporary, where does all your stuff actually live? Well, that's the job of the hard drive. This is the computer's long-term memory, its filing cabinet. All your files, your photos, your operating system, it's all stored here permanently. And unlike RAM, the hard drive is non-volatile, meaning it holds onto all your data even when the computer is completely turned off. So you can see how a computer absolutely needs both of these to work. You have the super fast, temporary RAM that acts as a workspace for active tasks, and then you have the slower, permanent hard drive that acts as the filing cabinet. They're constantly working together. When you open a program, the computer copies it from the hard drive into RAM so you can use it nice and quick. Okay, so our computer is built. But let's be honest, a computer that's all by itself isn't that useful these days. The real power comes when we get it connected and talking to other devices. And that's what a network is all about. At its most basic, a network is just a bunch of devices, laptops, printers, phones that are all connected to each other. This connection lets them share things. So instead of every single person needing their own printer, you can just have one on the network for everyone to use. It's how you can send files from one computer to another without a flash drive. Now, the kind of network that you're probably most familiar with is a LAN, which stands for Local Area Network. This is your home Wi-Fi network, or the network at your school or office. It covers a small, single area, like one building, and connects all the devices inside it so they can communicate with each other. But what happens when we want to connect beyond just our own building? How do we connect our computer to another one on the complete opposite side of the planet? Well, that's where we have to scale up from local to global. And the counterpart to a LAN is called a WAN, a wide area network. The only real difference here is the scale. It's huge. While a LAN is stuck in a single building, a WAN connects networks across massive distances. We're talking across cities, states, or even the entire world. And that brings us to the big one, the ultimate WAN. The internet is, simply put, the largest public wide area network on the planet. It's this gigantic global network of networks all interconnected that lets your little device here talk to a server thousands of miles away in seconds. But hang on a second, that brings up a really interesting question. You've got billions of different devices made by thousands of different companies, all trying to talk to each other. How is that not just total absolute chaos? How do they all understand each other? The answer is something called protocols. A A protocol is just an agreed-upon set of rules. It's like a common language for computers. These rules decide exactly how data should be formatted, sent, and received. It's because of protocols that a phone made by Apple can perfectly communicate with a server running software from Microsoft. They ensure everybody on the network is playing by the same rules. So we've built our computer, we've connected it to the global network. Let's zoom out one last time and see how these basic ideas are used to create all the different types of computer systems we have in the world today. Right, because computing power is definitely not one size fits all. At the very top, you have supercomputers, these massive machines built for huge scientific jobs. Then there are mainframes, which are the workhorses for big organizations that need to support thousands of people at once. A workstation is kind of like a desktop PC on steroids for intense technical work. And of course, you have handhelds, like the incredibly powerful computer sitting right in your pocket. But modern computing has taken things even a step further, with an idea called distributed systems. The concept is pretty amazing. What if you could make software run across a whole bunch of different computers and get them all to work together on one giant task as if they were a single system? You see this idea in a few different forms, like cluster and grid computing, but the one you and I interact with every single day is cloud computing. This is where companies build these enormous data centers just packed with computers, and then they rent out that computing power to whoever needs it. This is what powers nearly every app and website we use. So we've gone all the way from a single little processor to this global network of shared systems. The smartphone you're holding right now has more raw power than a supercomputer from just a few decades ago. It really makes you stop and wonder, with things changing this fast, what will the computer of tomorrow even look like?